When we look at Neptune, our minds often try to fit it into familiar categories, maybe a bigger, colder Earth with blue oceans and a solid surface. We imagine it as a distant cousin to our own planet, just waiting to be explored, mapped, and understood in the same ways we know our world. But the reality is far stranger and more fascinating than these first impressions suggest. But this is a misconception. Neptune is not a rocky world with a hidden ground beneath its clouds. There is no secret continent or vast ocean lurking just out of sight, waiting for a spacecraft to discover. There is no land to stand on, no ocean to sail, and no surface to plant a flag. If you tried to descend into Neptune, you would simply sink deeper and deeper into its thick, crushing atmosphere with no solid ground to ever break your fall. The blue color isn't from water but from methane in its atmosphere, utterly alien to anything on Earth. The methane absorbs red light, leaving behind that striking otherworldly blue that makes Neptune so mesmerizing from afar. Neptune is an ice giant, not a terrestrial planet. Its structure and environment are profoundly different from our home. Beneath its clouds, the pressure and temperature rise to unimaginable extremes, creating exotic forms of ice and gas that don't exist on Earth. Comparing Neptune to Earth is like comparing a house cat to a blue whale. Both are mammals, but their realities are worlds apart. The differences are so vast that our usual comparisons simply fall short. To understand Neptune, we must abandon our Earth-centric assumptions. We have to let go of the idea that all planets are just variations on a familiar theme. Forget the idea of a solid surface or gentle blue seas. Neptune is a world where the rules are different, and where our expectations are constantly challenged. Neptune is a cosmic laboratory, where the laws of physics are pushed to extremes. Its winds are the fastest in the solar system, reaching speeds of over 1,200 miles per hour, faster than the speed of sound on Earth. It's a world of immense pressure, bizarre chemistry, and violent storms. Lightning crackles through its clouds, and massive tempests rage for years at a time. The very concept of landing on Neptune is impossible. Any probe would be crushed and vaporized long before reaching anything resembling a surface. Its true nature challenges our definition of what a planet can be. Neptune forces us to expand our imagination and rethink what is possible in our universe. By letting go of our initial assumptions, we open ourselves to the staggering reality of Neptune. We begin to see it not as a failed Earth but as a unique world with its own mysteries and wonders. It's not a destination for explorers but a place that redefines our understanding of planets. Neptune is a reminder that the cosmos is full of surprises, and that our journey to understand it has only just begun. The universe is far more creative and more violent than our intuition allows. Neptune's storms, chemistry, and structure are a testament to the wild diversity of worlds beyond our own. The truth about Neptune is far more fascinating than any fiction we could invent. By embracing its strangeness, we gain a deeper appreciation for the endless variety and wonder of our solar system. Neptune is often called a gas giant, but that's misleading. It's actually an ice giant, a crucial distinction. Ices in astrophysics means volatile compounds like water, ammonia, and methane, not just frozen water. Inside Neptune, these ices exist in a hot, dense, supercritical state, neither solid nor gas. This slushy, electrically conductive mantle surrounds a small, rocky core. Unlike Jupiter, which is mostly hydrogen and helium, Neptune's bulk is made of these heavier, icy materials. Its visible atmosphere is just a thin skin. The real planet lies beneath in that deep, churning mantle. Neptune's composition is a direct result of where it formed, far from the sun, in a region rich in volatile compounds. Calling Neptune an ice giant isn't just semantics, it's about accuracy. This distinction helps us understand its storms, magnetic field, and frigid nature. Neptune's true nature is layered, complex, and utterly unique among the planets. If you could descend into Neptune's atmosphere, you'd find a toxic mix of hydrogen, helium, and methane. Methane gives Neptune its blue color by absorbing red light and reflecting blue. There's no oxygen, no chance for life as we know it. Neptune's winds are the fastest in the solar system, reaching over 2,100 kilometers per hour. These supersonic winds create massive storms like the Great Dark Spot. As you go deeper, pressure skyrockets, thousands to millions of times Earth's. Any spacecraft or human would be crushed instantly. The atmosphere gradually becomes a supercritical fluid. There's no clear boundary, just a crushing descent. Temperatures at the cloud tops are frigid, around minus 225 degrees Celsius, but soar to thousands of degrees near the core. Neptune is a world of savage extremes, freezing cold, searing heat, and relentless pressure. The idea of a surface is meaningless here. It's a truly hellish place, utterly inhospitable to life. Imagine being teleported into Neptune's upper atmosphere in a standard spacesuit. At first you might see the swirling blue clouds and the endless expanse below, but the danger is immediate and overwhelming. You'd be crushed by the pressure in an instant, your suit and body flattened before you could react. The force here is so immense it's like having the weight of an entire ocean pressing down on every inch of your body. Even with a suit that could withstand the pressure, the cold would flash freeze you at minus 225 degrees Celsius. The temperature is so low that metal becomes brittle, and any exposed electronics would fail almost instantly. The environment is so hostile that survival isn't just unlikely, it's physically impossible. Neptune's storms rage with winds faster than any hurricane on Earth, adding another layer of danger. No technology could protect a human here. Neptune is for robotic probes only. Machines can be engineered to survive, but even they have limits in this extreme world. Its crushing pressure and lethal cold are a cosmic 1-2 punch. The deeper you go, the more intense and unforgiving the conditions become. The laws of physics are simply not on our side. Nature's rules here are absolute, and they leave no room for human life. Neptune is a powerful reminder that the universe is not designed for us. Its beauty hides a reality that is utterly inhospitable. Many worlds like Neptune will always be off-limits to human explorers. Our technology can visit, but our bodies never will. Its hostility is a lesson in humility. It reminds us that, despite our achievements, we are still at the mercy of the cosmos. We are fragile visitors in a universe that is largely indifferent to our existence. Our home is rare and our survival is precious. Neptune's environment is a stark warning. Not all worlds are meant for us. It's a place where only machines dare to go, and where humans can only dream from afar. Neptune's gravity defines the edge of the classical solar system and played a key role in Pluto's demotion. Pluto was once the 9th planet, but discoveries in the Kuiper Belt forced a rethink. The IAU set 3 criteria for planethood: orbit the Sun, be nearly round and clear its orbit. Pluto fails the 3rd test. It crosses Neptune's path and hasn't cleared its neighborhood. Neptune, by contrast, dominates its orbit, setting the standard for what a planet should be. Pluto's erratic tilted orbit and its crossing of Neptune's path sealed its fate. Neptune's gravitational influence forced scientists to refine our categories. The contrast between Neptune's stability and Pluto's chaos is clear. Neptune became the benchmark for planethood in the outer solar system. Its role in the Pluto debate highlights the complexity and evolving nature of planetary science. Some still claim planets are flat, but Neptune is irrefutable evidence to the contrary. When we look at Neptune, we see a world that defies the flat planet idea at every turn. Gravity shapes massive objects into spheres, pulling matter evenly toward the center. This process is universal, affecting every planet and star we observe, no matter where it is in the cosmos. Neptune, with over 17 times Earth's mass, is a near-perfect sphere, just slightly flattened at the poles due to its rapid rotation. This immense mass and speed create forces that shape Neptune in a way no flat object could ever mimic. This shape, called an oblate spheroid, is predicted by physics and seen in all large spinning bodies. The laws of motion and gravity work together to create this familiar rounded form. We've photographed Neptune from multiple angles and watched its moon's orbit. A flat disk couldn't explain these observations. The way Neptune's moons move around it only makes sense if Neptune is a sphere. The evidence is overwhelming. Neptune is round because the universe's laws demand it. Every image, every measurement, and every mission to the outer planets confirms this truth. Its slight equatorial bulge is further proof of these forces at work. This bulge is a direct result of Neptune's rapid spin, a detail that flat planet models simply can't account for. Neptune's existence debunks flat planet myths and affirms our understanding of gravity. It stands as a clear example of how science explains the shapes of worlds. The universe shapes worlds into spheres, not disks. This is a pattern we see repeated everywhere, from the smallest moons to the largest gas giants. Neptune stands as a beautiful testament to the consistency of physical laws. Its very existence is a reminder that the universe is governed by principles we can study and understand. The cosmos operates by rules we can observe and understand, and Neptune is one of the clearest examples of these rules in action. Neptune is full of quirks that set it apart. Its day lasts just 16 hours, despite being 4 times Earth's diameter. a rapid spin that fuels its wild winds. Neptune has faint, clumpy rings, shaped by the gravity of its moon Galatea. Its largest moon, Triton, orbits backward and spews nitrogen geysers, hinting at a geologically active interior. Neptune was the first planet discovered through mathematics, not direct observation, a triumph of human intellect. Its deep blue color, caused by methane, is still a bit of a mystery. Uranus has methane too, but is much paler. Scientists suspect another unknown compound gives Neptune its vibrant hue. These mysteries make Neptune a world of wonders, not just a data point. Every discovery reveals new surprises and deepens our curiosity. Neptune's quirks remind us how much there is left to learn. Understanding Neptune is a testament to the power of critical thinking. Science isn't just facts, it's a process of questioning, testing, and refining our ideas. Our evolving view of Neptune shows how challenging assumptions leads to deeper truths. The Pluto debate, for example, was born from critical thinking and a willingness to update our definitions. Categories are human inventions. Nature is often messier than our boxes. Approach space and life with curiosity and skepticism. Ask questions, seek evidence, and embrace the unknown. The universe rewards those who think like cosmic detectives. Why care about Neptune? Because it's the frontier of our knowledge and a symbol of human curiosity. Studying Neptune pushes our scientific models to their limits and informs our understanding of planets everywhere. Its extreme environment highlights how rare and precious Earth's conditions are. Neptune's discovery was a triumph of mathematics and intellect, not just observation. Every new finding is a testament to our drive to explore and understand. Neptune challenges our assumptions and showcases the scientific method in action. By studying it, we learn about the universe and ourselves. Neptune is more than a blue dot. It's a symbol of the unknown and the power of inquiry. The quest to understand Neptune is part of our grand journey to understand everything.